Okay, hi, I'm Will. I'm a developer here at Carbon 5, and today I want to talk about applying Elixir patterns in JavaScript. So Elixir, I think, spoils you. If you're here at Elixir meetup, you'll probably agree with me that Elixir is a particularly pleasant language to program in. It has a lot of performance benefits as well, but it's just like, it's nice. And whenever I'm pairing in another language, I feel like Phoebe from Magic School Bus. Like, in my old school, well, in Elixir, we could have used a pipe for this. Whatever. I think my pairs get annoyed at that sometimes. But the point is that JavaScript is definitely a place where that happens, where you're like sort of bummed out that maybe you're not working in Elixir. But the gift and curse of JavaScript is that it can be anything you want it to be. You know, there's just like a wide range of patterns. There's not a lot of really hard and fast idioms, and that can make it really messy, but it also means that you can kind of do things the way you want. And so if you're working on a project that's an Elixir project, and everybody on the team is into Elixir, then it might make sense to port some of the patterns and idioms from Elixir into JavaScript. It definitely is not there for every team because like some of this stuff won't be the like current popular idioms. So here are 3 patterns that we can maybe pull in from Elixir to make our JavaScript code a little better. Modules. If we can organize our data structures and functions to basically replicate the way Elixir modules work. Contexts. Phoenix has some really good ideas about how to organize your application, how to split up your web code from your business logic. And it turns out those ideas are equally good in the front end. And then finally, pipelines. The pipe operator is definitely one of the best parts of Elixir, and you can get most of the way there in JavaScript without any stage 1 syntax magic. Yeah, so to have something kind of concrete to talk about, I'm going to go through building a simple payroll application. I think it's something that would let like an hourly employee put in how many hours they worked this week and how many hours they worked today, and then would calculate how much they would make that day. I think it's nice to have something a little more complicated than a to-do app to look at, so you can like see how things will sort of act a little more in the real world. And what makes payroll a little complicated is the like California wage and hour laws. So fair warning, the next slide is extremely boring, but there they are, the California overtime laws, which essentially boil down to, you know, you get paid your hourly rate straight time for the first 8 hours, and then, you know, time and a half for the next 4 hours, and then double time after that. Except if you've worked 40 hours of straight time already, like if it's a Saturday, then you get time and a half right from the get-go. And if you're on the 7th day consecutive working, no matter how many hours you worked, you start with time and a half for the first 8 hours, and double after that. The important part is that your pay is a function of the current hours you worked this week or the hours you worked today and the hours you worked earlier in the week. So we can imagine a situation where we've built a beautiful Elixir Phoenix backend that is calculating pay and serving it over an API. But now product comes and they say, hey, you know, users want to be a little more interactive. They want to be able to put in numbers and see immediately, you know, how their hours will affect their pay. So we're going to make a React app that performs the same calculations that we have in our existing Elixir system. And so as Elixir devs, we might be disappointed to hear that because now we're leaving happy Elixir land. So let's see how we might be able to like sort of ease that burden a little bit. For the record, here is the app. As you can see, it's a great example of web brutalism, which is, you know, it's a hot design trend right now. You put in your hours, make sure to comment illuminate those, and then your hours today, and it calculates your overtime. Awesome. Okay, so first up, modules. So this is a pretty standard Elixir module. You can define a struct that describes the shape of the data that the functions in this module will be working on. So this is the employee module. So we have a def struct that says employee as a name and a title and a wage. Optionally, you can have a type that says like the wage is a number, whatever. And then it has some functions that specifically work on employee structs. So both based on the type spec and the definition, we're pattern matching to say like, okay, this takes an employee generally as its first argument, is sort of the idiom in Elixir. And so this is a great way to organize our code. Like it's in some ways like a class where you have the data and the logic that works on the data all in one place, but without the overhead of state. So how would we do this in JavaScript? We certainly could write a real class, which would be an option, but if we're Elixir developers, we don't probably want to do that. We'd like to have something a little more functional. And if we're writing something like React, classes aren't going to work for a lot of things. You can't put a class in a Redux store. But it turns out we can build basically the exact same module in JavaScript. We can use JSDoc, which is sort of like a standard way of defining documentation to describe the shape of our struct. It's an employee, it's got the same names, titles, wages, the same types, and then we can define export functions that take that employee struct, and we can even destructure it in a similar way that we would pattern match in Elixir. So, I mean, this is, functionally copy-paste job, except for switching the to camel case. And that's nice. So we can get these like benefits of this functional module system. If you're writing in TypeScript, and if you are, good choice. This works even better. You can define a real interface and can have compile time checks that say, like, indeed, as in Elixir, you're definitely getting an employee here, instead of just relying on destructuring. And then, so once you have a module in Elixir, to actually use it, generally what you're going to do is in some other module, you're going to alias it so that you can refer to the module just by its name instead of the nested path. But you do generally alias rather than import. So you're saying employee.pay. And it's very clear that pay is an employee-based function that takes employees. In JavaScript, it's, on the other hand, it's common right now to import functions by name with the curly brace syntax. This is a little shorter, and it helps Webpack figure out if there's dead code that it can eliminate, which is nice. But you miss out on the prefixes, that it's not clear unless you actually look at the import statements whether pay is a variable or the what. So happily, you can do whatever you want in JavaScript. So the import star syntax gets us back to Elixir-style modules. Now we've got our functions that are prefixed with the module name, just like in Elixir, and it's very clear how we're using them and what they mean. So great. All right, modules, done. Elixir modules. Next up is pipelines. So again, the pipe operator, amazing part of the language. It lets you write these beautiful pipelines of functions with the return value from each function feeding into the next one as the first argument. So for instance, here we've got to actually do the work of calculating the overtime in our little app. We're taking the previous hours, we're piping it through something to just get the straight time component of each day, summing it, and then combining that with the count of the days and the hours of today to get your actual pay. And it's in this nice, step-by-step instructions. So how about JavaScript? Well, pipe is actually a stage 1 proposal in JavaScript right now. Except that it's actually 2 different competing proposals about like how it's going to work. It's totally in flux. Babel does support them, so you could at least like play with using pipe in JavaScript right now, but it's certainly not production ready, and like whatever you do now will like definitely change. So though there may come a day where we can use the pipe operator in JavaScript, it is not this day. So what can we do? We can get pretty close with libraries like Ramda or Lodash-FP. They're a topic for a whole other talk, which I've given. But basically, they're these functional utility libraries that are similar to something like Lodash or underscore, but the big difference being that their functions are all curried, and they take their data parameter as the last argument. And that means, so how does currying sort of play out? depending on how you've run into this. Normally, if I wanted to write a function, say, that just added two numbers together, I would do it in sort of the standard way. You'd have a function that takes an x and a y, and then it adds, that's that. And if I wanted a function that, say, always added 1 to a number given to it, I might do something like write a new function that takes x and then passes it to this basic add x and 1, and that adds them together. Or just do +1, whatever, for the example. So that's fine. But with currying, you can be a little more concise. Instead, the next three functions are all examples of something like currying. You can either write a function that, depending on how familiar you are with the ES6 syntax, that partial add is a function that takes x that returns a function that takes y that adds the two together and returns the value. So that's fine. And then, so if we just call partial add 1, then we get back a function that, when given a y, will add 1 to it. Ramda has a curry function that sort of does that magic for you. You call it on a function that takes 2 parameters and it turns it into something you can call one at a time. Or you could just use Ramda's add, which is already part of the library and already is curried by default. So just calling add 1, again, gives you a function that, when called, will add 1 to whatever number it's called with. So you can see that however you call these things, they work the same. So that is currying. And the important part is that it allows you to take a function that takes many arguments and turn it into a unary function. It's a function that is waiting for a single argument, which is similar to how piping works, how the pipe operator works in Elixir. So this is where the magic happens. Once we have these curry functions that have been partially applied, so they're all waiting for a single value, you can use them in Ramda's or Lodash's pipe operator, or rather pipe function. It works basically the same as the Elixir operator, where you can give it a list or a series of functions, all that are waiting for a data argument, and then instead of at the top, in here, it's at the bottom, you pass in the argument, and then it threads it through the entire pipe. So it's true, the syntax isn't quite as awesome, and you do have to go through the trouble of actually having curried functions. And there's a little bit of mental overhead where in Elixir, your data parameter comes first, because that's where piping puts it. With currying, your data parameter goes last, because you need to give all the other parameters, so you have it just waiting for the data parameter. So that's like switching back and forth can be annoying sometimes. But it means that you can write this exact same pipe logic. So as a reminder, here's the Elixir implementation, and here's the JavaScript implementation. I mean, it's you're writing the same code, the same logic. Mapping, calling out to this remove overtime function, summing. It's all there. You even have basically the same, you've got constants in JavaScript, or in Elixir, your, whatever they are, the compile time constants. So it's allowing you to write things the way that your brain works if you've been doing Elixir for a while. Okay, so the last one is context. We've got our functions piping data and organized into modules, but the surprisingly hard question in JavaScript always is where do I put my files? It's weird that we haven't decided, but there we are. So Phoenix 1.3 introduced this concept of contexts as a way to organize your code. And it suggested that you've got should make that a little bit bigger, that's okay. It looked really big on my screen, it's fine. Okay, so it suggests that you have a payroll, a web directory that has all of your framework code that interacts with the web. Things like controllers, views, templates. And then separately, you have your business logic that is in these contexts that are these groups of related, cohesive bundles of structs and functions that all sort of work together and talk to each other a lot and don't get outside of the context that often. So you can see here, for this system, I've got, or maybe you can't see it, but I've got a payroll within the payroll system, I've got an employees context, and then an hours context. And the hours context does the actual math, figuring out how many hours, and the employees context knows about their wage, so we can figure out how much they're paid. Yes. So in JavaScript, oh, the other thing is that each context has a single public interface file that pulls together functions from other modules within the context and re-exports the ones that it expects the web component or other context to want to use. And those are named the same name as the context. So the employees context has an employees.ex, and that's the public stuff. So in JavaScript, there are infinite ways to structure your code, but this we can definitely do. So this is the structure for this React project, but it would work fine in Angular or whatever. And it's basically the same premise. You've got your framework code, your web code, off in this payroll rev directory. And then totally separately, you've got a payroll directory that has all of your business logic in it, separated into the employees and hours contexts. Each of them is an index.js, which is the public the file that re-exports the public functions. So the same setup works quite well in Elixir. So the employees context file, the public file here, for instance, is in this case just using def delegate to delegate out to other modules. It sometimes also has its own functions that are sort of gluing together logic from different modules. But yeah, that's that. And then in Elixir, we can do the same thing. Or rather, in JavaScript, we can do the same thing. We can import functions from other modules in context, and then re-export them as public, context public functions. And because it's an index.js, you can just say import from, /employees. And then finally, in the Elixir app, on your website, your controllers are mostly just pulling together code from your contexts and dealing with web-specific stuff. So for instance, this, which is the API endpoint that also does these payroll calculations, knows about things like parsing the strings that come in from the user. But other than that, it's calling out to your context code. And all the complicated logic is implemented and tested outside of your web context, where it's easier to think about. And JavaScript, once again, same premise. Our React component is calling out to the context for all of its actual business logic, and it's just worried about presentation stuff. It knows about state, and it knows about parsing strings, and that's it. Other than that, again, pushing out to the contexts. That same nice separation of concerns that we get in Phoenix, we can absolutely have in JavaScript. So with modules, pipelines, and context in JavaScript, you can essentially Elixir all the things. Thanks.
Questions?
Yeah.
The title is Elixir patterns.
Yeah.
Do you feel like these are specific to Elixir patterns?
Oh, yeah. So for the YouTubes, the question was, are these patterns actually specific to Elixir? That's a good point. No, not necessarily. Certainly, pipelines show up in a lot of the NL-based functional languages, Haskell, Ockelmann, that kind of thing, or the pipe operator rather. Modules as well, and are pretty common in the functional world. Contexts, I mean, that's brought from domain-driven design. So certainly, the idea of a bounded context is, domain-driven design, I think, was written mostly about in the Java days, so that's common. But
it's called interfaces or something.
Yeah, I think. Yeah.
Interface, yeah.
Slightly different.
Yeah, interface is the specific Java construct. That's more at the class level. The context here is this. It's not even in the language of Java. It's just it's a popular way of organizing files.
Right. You can. It's sort of somewhere between a monolith and microservices, where you have chunks of code that you can kind of think about as one group without spending too much time thinking about other things. And so if you bundle that all together, then you can have a separation of concerns. So yeah, that's definitely is a common idea, though the specific implementation that Chris McCord came up with for Phoenix 1.3 is this. Yeah?
How natural would it be doing that in JavaScript? Elixir obviously is part of the language, but it goes how did this doing this here, did it feel like too much of a hack, or is it something where it was comfortable enough where you would consider using it, every day?
Totally. Yeah. So the question was, did this feel like a weird hack, or trying to get the language to fit something it's not supposed to, or did it feel good? I think it felt great. I do a lot of this stuff in my personal projects because we work for clients. We're generally trying to stick to community best practices, which I think is a good idea. But when I write, I use Ramda in everything that I can. I just got it in a client project today, which I'm very happy about. Yeah, I really like the import star thing. Having those module prefixes makes me really happy.
Yeah.
I like to write TypeScript for my front end, and so I definitely always do the modules where it's got an interface with a type T and functions that operate on a type T. I think it's a really nice, yeah.
Certainly in JavaScript, you have the freedom to mess with it as you like, because it's basically classes and functional programming if you want.
But yeah, definitely nothing here I think is a super hacky. You're using the normal parts of the language, import star and re-exporting imports and
yeah. Ultimately, the only thing you couldn't hack is the
thing.
What?
Oh, well,
you can't hack the underlying concurrency model. There's no way to get out of the JavaScript event.
For sure.
Yeah. Pure script, as you had mentioned on Hassel, I think the guy's even local, and I think he works at some company actually in downtown LA. But a lot of the JavaScript, I played around with CloverScript a long time ago, and it got to the point while they were powerful that the communities were kind of small. I don't even know if anybody other than uses pure script, so that's what I was kind of wondering. The libraries or just making things more user-friendly from that point of view. Is it too much of a hack, or you might as well just use what the language naturally from best practices allows you to do? That's so I said Mutable. I do personally use TypeScript, and it's it's gained so much community support that it's become sort of part of the best practices. Whereas I think I've heard about it before, but I don't know if anybody that actually uses it.
Yeah, it's a little less popular. That said, it also interops fine with whatever. Immutable, you have these special immutable data structures. You have to go in and out of pure objects. But Ramda just takes an object or an array and does some stuff with it. So it'll work with.
Also, the fun thing about JavaScript best practices is they change faster than any other language on the planet. So Ramda might be the hotness in a month.
Yeah.
You did say you were going to come back to it. The two theories that they're going to go with the next ES with pipelining.
Yeah. Oh, yes. That's a great point. Yeah. So what are the two different competing pipeline ideas? Yeah. I was reading the GitHub issues about it recently. It is quite heated sometimes, which is funny, but also reasonable because we'll be using it. It seems like one of them is something really similar to the way is based on the ML style. So it would be similar to this, where it works with current functions, and it would work like this, except that you'd have the pipe operator. So the data argument would still be last instead of first. The other one is that there'd be a special character, I believe, that would be a placeholder character that you could put in. You would write a function call after the pipe, and then you'd put this special placeholder character that would say this is the place where the data should be piped.
Yeah, there's basically a question of it's really easy to do if you only accept functions to take a single parameter, and you don't allow inline arrow function syntax, and so that there's a so-called minimal proposal, which is we're gonna take out all the hard stuff. And then there's these two competing, here's a more full-featured proposal. There's also really interesting questions around asynchronous functions, which are now in JavaScript. Does it support that? Does it not support that? Because there's a whole bunch of issues there. It's pretty interesting if you're there's the so-called F-pound proposal, and
I think that's the F sharp.
The F sharp.
That's the ML based.
Yeah, and then there's the so-called smart pipe proposal. Yeah. So anyway, it's online. I mean, probably none of us are going to have any say. Though they are looking to see which one becomes popular in community usage, I think.
Right.
Yeah.
Which is, I think, why Babel supports both of them. So that you can use it and then say that you're using it.
Yeah.
And beta test it or whatever.
Yeah.
Maybe alpha test it.
Yeah, alpha.
Yeah.
Stage 1 is definitely alpha.
Oh God, unless you want to be married to that code base.
Yeah.
Yeah, right.
Are there certain groups that, I don't know why I just think, thought about this, because I'm actually, like, I'm thinking about blockchain. Speaking of the async, that there's something called Web3, like the standard front-end thing. All the code there is actually async. So using the async keyword, where it's like most of the stuff I actually look at, like React, Redux, is all, like, some's async, but most of it's not.
Yeah.
So I'm just wondering, like, are certain communities, like, maybe more of the functional, like, sharp people are like, okay, we want it to be this way, whereas, like, another group is like, no, we want it different.
You mean when it comes to language features?
Yeah, the feature you're talking about, that's...
There's definitely some like there's a repo on. I don't want to like go too far off topic. There's a repo online called TC39 meeting notes that, like, if you want to read some dry meeting notes that you could see conceal massive drama just from reading them. I'm reading this. I'm just like, I can't imagine what it's like to be in the room right now. Because the TC39 committee is like, the Council of Elrond up there, and but definitely with like the older more experienced wizards who are maybe getting a little set in their ways, Yeah. So anyway, all right. Well, now my ageism's on video. Go ahead.
You always cut.
Yeah.
Any other questions? Awesome. Thanks.